Step outside tonight. Give it 5 minutes. Just look up. If you're lucky, you'll see something you've probably stopped noticing. The moon. But tonight, I want you to actually look at it. Not a quick glance. Really look. Try to picture what it actually is. It's a rock. A genuinely massive rock. About a quarter the size of Earth. If you were standing on it right now, your feet would be in actual dirt. You could walk across it. It would take you months to get from one side to the other on foot. That's how big this thing is. And it has been orbiting our planet for billions of years. Faithfully. Tirelessly. Without a single day off. So when I see a full moon, here's what immediately crosses my mind. We, humans, have sent rovers to land on that rock. Multiple times. We've driven vehicles across its surface, and not just once, but 6 separate times. We've put actual human beings up there, walking around on it like it's completely normal. Think about that for a second. If you had looked up at the right moment in July or November of 1969, February or July of 1971, or April or December of 1972, there were people up there, walking around on the moon. That genuinely messes with my head. Here's why. In the entire 4.5 billion year history of Earth, our species only evolved 300,000 years ago. We figured out farming just 10,000 years ago. Modern science is only about 400 years old. Powered flight? 120 years. And yet, within the last 70 years, we've broken through the boundaries of this planet entirely. Do you see how exponential that is? How fast we're accelerating? Where will we be in 50 years? Honestly impossible to imagine. But here's the thing. As incredible as that acceleration is, we have to be honest. Landing on the moon is now a pretty old achievement. Most people watching this weren't alive for it. Because since the Apollo 17 mission in 1972, no human being has set foot on the moon. That's nearly 54 years. So for most of us, the moon landings exist only in books and documentaries. Don't get me wrong, the past 5 decades have been extraordinary. We built the International Space Station and China's Tiangong Station, engineering marvels that have no parallel. We launched thousands of satellites, deployed world-class space telescopes like Hubble, Chandra, and the James Webb. We even figured out how to land rockets back on Earth and reuse them. Remarkable stuff. But here's the uncomfortable truth. The physical human body hasn't gone beyond low Earth orbit in 54 years. When you hear about astronauts going to space on the news, that's the space station, orbiting just 400 kilometers above us. And when you hear about celebrities going to space, that's barely 100 kilometers up. Tourism. A sky-high roller coaster. The moon is 384,000 kilometers away. Getting there is a completely different beast. Harder, more expensive, and far more dangerous. So without a compelling enough reason to go back, we just didn't. But that is about to change, barring weather delays or technical issues. And NASA has had plenty of both. The Artemis 2 mission may be launching as you watch this video. A brand new spacecraft called Orion, sitting atop the massive Space Launch System rocket, taller than the Statue of Liberty, will carry 4 astronauts on a loop around the moon and bring them safely back to Earth. In other words, if nothing goes wrong, humans are going back to the moon right now. So let's talk about it. Let's talk about Artemis 2, about whether we actually went to the moon, and about why we're going back. When Neil Armstrong took that first step in 1969, one small step for man, one giant leap for mankind. It seemed like the beginning of something unstoppable. And yet, here we are in 2025, and some people genuinely believe the whole thing was faked. We actually sent our own team out to ask people on the street, and even among science enthusiasts, the skepticism was surprisingly real. I think maybe they planted a flag, but honestly, who knows? I don't think they actually did it. Maybe they went later, once they'd already committed to the lie. Okay, let's clear this up. Not with 80% confidence, not with 95%, with 100% certainty. First, the thing everyone seems to forget. We didn't land on the moon once. We landed 6 times. Apollo 11, 12, 14, 15, 16, and 17. 24 astronauts made the journey. 12 of them walked on the surface. Are we saying all 6 missions were fake? All 12 moonwalkers were lying? Second, the Soviet Union, America's greatest rival at the time, tracked every single one of these missions with their own radar, their own intelligence agencies, their own equipment. And not once did they claim it was staged. Think about that. If America had faked the moon landing, the Soviets would have loved nothing more than to expose them. They stayed completely silent because there was nothing to expose. Third, space agencies from Europe, India, China, Japan, and Russia have all since sent their own probes to the moon. Every single one of them has photographed the Apollo landing sites, the equipment, the footpads, the tracks. Why would countries with competing interests all cover for an American lie? And fourth, the physics. The astronauts left retroreflectors on the lunar surface. Precision mirrors. Laser ranging stations on Earth shoot lasers at these exact targets to this day, using the return time to measure the moon's orbit with extraordinary accuracy. If nobody went up there and placed those reflectors, what exactly is bouncing our lasers back? Plus, hundreds of kilograms of moon rocks and soil were brought back and studied independently by thousands of researchers at dozens of institutions worldwide. None of it matched anything on Earth. So no, the flag wasn't fluttering because of wind. The shadows aren't weird. The dust wasn't behaving strangely. Those objections are a mix of childlike imagination and stubborn ignorance. We don't believe humans walked on the moon. We know it. So then the more interesting questions. Why didn't we go back for 54 years? And why are we going back now? The answer to the first question is simply politics. The Apollo missions weren't driven by a sudden obsession with the moon. They were driven by fear. The Soviet Union had launched the first satellite, the first living creature into orbit, the first human in space, the first woman, the first spacewalk. The space race was on, and it was directly tied to military power. America poured billions into catching up, and winning the moon was the ultimate prize. Once the Cold War thawed and the Soviet Union eventually collapsed, the political justification for spending billions to send humans to the moon evaporated, and robots had gotten good enough to do the actual science without risking human lives. So over the past 54 years, we learned enormous things about the moon through robotic missions. Its geology isn't dead, as we once thought. There's water ice. We've mapped its surface, analyzed its interior, traced its history, all without a single human in the loop. The right tool for the job, right? But now the job has changed. We're not going back to plant flags and take photos. We're going back because we're ready to stay. The next 50 years of space exploration have a roadmap that runs through the moon. The plan goes roughly like this: build stations in Earth orbit. Check, already done. Build a base on the moon's surface and in lunar orbit. Use those as staging points for missions to Mars, and from Mars, eventually spread further into the solar system. Think of it like building a highway across a continent. You don't just leap from one city to another, you build rest stops, fuel stations, infrastructure. The moon is our first rest stop beyond Earth. And here's what makes the moon especially strategic. Its gravity is only 1/6 of Earth's. Launching from the moon requires a fraction of the energy. So if we can manufacture rocket fuel there, using the water ice locked in permanently shadowed craters near the South Pole, the moon becomes a kind of cosmic gas station for the entire solar system. There's also a new space race driving all of this. China has made extraordinary progress in space over the past 2 decades. They're launching their own astronauts, building their own space station, docking vehicles autonomously, and doing some of it more efficiently and cheaply than NASA. That's a wake-up call. So the Artemis program, named after Apollo's twin sister in Greek mythology, is America's answer. Now, a quick note on what Artemis 2 actually is and isn't. It will not land on the moon. Artemis 2 is the second step in a multi-phase program. Artemis 1 in 2022 sent an uncrewed Orion capsule on a successful loop around the moon. Artemis 2 does the same thing, but with 4 people on board. The actual lunar landing is now planned for Artemis 4, targeting 2028 or so, most likely with some delays. That mission aims to put humans on the moon's south pole for the first time ever, and begin construction of Gateway, a lunar space station that will serve as the hub for long-duration missions. Artemis 2 is also launching the most diverse crew in the history of human spaceflight. Commander Reed Wiseman is an experienced pilot. Christina Koch will become the first woman to travel beyond Earth orbit. Victor Glover will be the first person of African descent to venture into deep space. And Jeremy Hansen represents the Canadian Space Agency. Compare that to Apollo, an all-white, all-American, all-male crew, and you see why the diversity here actually matters scientifically. To understand how deep space affects the human body, you need data from across the full range of human biology. How does a female body respond to deep space radiation compared to a male body? How do different genetic profiles respond to microgravity? In an era where we already know medications work differently across populations, this isn't just symbolism, it's good science. The mission itself will last roughly 10 days. Here's how it unfolds. Just 8 minutes after launch, they'll officially be in space. Within about 50 minutes, they'll reach a parking orbit. After roughly an hour and 48 minutes, they'll move to a higher Earth orbit, where they'll spend 23 hours checking every system. Life support, water, CO2 scrubbers, cabin pressure, before committing to the moon. On day 2, the main engine fires the translunar injection burn, the precise boost needed to escape Earth's gravitational well and fall toward the moon. Over the next 2.5 to 3 days, they'll cross roughly 384,000 kilometers, making 3 small trajectory corrections along the way. By day 5, they'll be fully in the moon's gravitational field. Day 6, they'll swing around the far side, coming within 6,500 to 10,000 kilometers of the surface. And for 30 to 50 minutes, they'll be completely out of contact with Earth. The moon will physically be between them and us. On day 7, they'll use what's called a free return trajectory, essentially a gravitational slingshot. They'll use the moon's own gravity to whip themselves back toward Earth, with only minimal rocket burns needed. This is orbital mechanics at its most elegant, nature doing most of the work for free. Days 8 and 9 are spent testing radiation shielding, manual piloting procedures, and other critical systems. Day 10, they re-enter Earth's atmosphere and splash down in the Pacific Ocean. That's the mission. No landing. But it's not supposed to land. It's a dress rehearsal. A high-stakes test of every system that will eventually carry humans back to the lunar surface. Artemis 2 isn't just a mission, it's a key. If it succeeds, Artemis 3 and 4 become much more achievable. And with them, the beginning of a permanent human presence on the moon. So the next time you step outside on a clear night and see that bright, familiar glow, remember, 4 human beings sharing the same evolutionary roots as every person who's ever looked up at that same light are tracing an arc around it, carried there by science, by engineering, by curiosity that refused to stay grounded. The one thing I'm genuinely most moved by? At some point during the mission, those 4 astronauts will swing around the far side of the moon, cut off from every human voice, every signal, and look back. They'll see our pale blue dot suspended in the absolute blackness of space. Small, fragile, and alone. I hope they share that moment with us. Keep looking up.